Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? All right. Dun, dun, dun. Lucio says, let's go. What's up, Lucio? What's crack-a-lackin'? Today is Monday, start of a new week. That's awesome.
That's dope.
We're streaming a little bit later than I usually do on Mondays. Usually I stream starting at 3 p.m. Pacific, but I had to go to the dentist today at 3:15. It looks like I gotta go back to the dentist tomorrow because they want to like put a crown or something. I don't know. Yes, I do remember you, Lucio. You're cool, dude. What's up, Chantrix? Yeah. So yeah, we're back. Today's Monday. I taught. What did I teach today in class for UCLA? I taught. Torque. I talk about torque. Torque is really cool. It's like a rotational force. Very useful when thinking about like tightening things and like loosening things or like trying to like, you know, get a jar open. It's a lot of torque. Otherwise, what up, y'all? Yeah, what's up, dude? Second week of AP exams is this week, so I know there are a lot of students taking AP Calculus, I want to say today. Is AP Calculus? And then AP Physics, I believe, is on Thursday. Wait a minute, no, maybe it's on Friday. No, I think AP Physics is on Friday. Because on Thursday, I'm going to do an AP Physics 1 live stream review. We're going to do an extra stream where I'm going to help out kids with AP Physics 1. So, if you want to come by and get help with that, you totally can. Or if you just want to learn some physics, like, come on by. You know my friend Joe Smith? He goes to UCLA. He's one of your students. Joe Smith sounds like a pretty generic name, but maybe. I have 188 students in my class, so it's like it's kind of hard for me to remember everybody's name. But I'm sure there is a Joe in our class. Let's see. Other news that's happening. Oh, yes. I don't know if you guys saw the announcement. I made an announcement on, what was it? On Friday? Did I do this on Friday or Thursday? I don't know. The days start blending a little bit too much. But, okay, yeah. If we go to, here, let me just see. Within the Discord, I made an announcement. It's under announcements. Right here. Oh, it's showing the wrong screen. One sec. I gotta remove that. Get rid of this. Okay, there you go. Now this is showing correctly. Yeah. Here I made an announcement about things. So basically told people that, yeah, I've been teaching UCLA, so I've been a little bit busy. But we've also started streaming on YouTube and TikTok, as you guys have seen now. And we've made it even easier for people to submit questions because they can just do so with this new website. You can still post things in Discord. I appreciate that. But if you're watching from other platforms and you don't, have time to log on to Discord, we do have a website to submit questions. Oh, also, yes, our friends at Wibbly, Nick, he just joined the server. He's a very cool guy, but he's doing a thing about geometry. So geometry is always, I call it like the ugly stepsister of math. It's because it's one of those weird maths where you're doing things with like shapes and like lines, and it's a lot of learning properties and like classifying stuff. So, anyways, he's come up with this really cool method of learning it using what are called like knowledge trees, which to me kind of reminds me of nodes and stuff. I don't know if anyone's ever seen like hyperphysics. Hyperphysics does this. Wait, what? Dude, what? What's wrong with Hyperphysics website? Just go to Hyperphysics, please. Okay, here we go. It's such an old school website, probably that's why. But Hyperphysics loves to, for instance, show how things are related using like trees. So for instance, E and M can then be taken down into electric circuits. And then within electric circuits, you can do DC circuits or current law or this. So it's a way to like branch out how to like learn a lot about a different topic. And geometry is very similar in this, that it's a, there's a lot going on. So one sec, let me get the thing back up. AP Pre-Calc is tomorrow. Oh, that's cool. Good luck if you're taking that. I don't know what college credit that actually counts for, but anyways, so he's created this website called Wibbly, or I think it's like a platform. It's a whole platform. And so let me show you. Let me pull up a little demo of like what it is. So what we're gonna do as a part of the server here is, and he's been so generous that Nick's gonna donate some prizes and stuff if you guys just go through it. It takes like 20 minutes, super easy. I'll explain this more on Wednesday when we open it up. But in general, what happens is you sign up for again, it's a free website they use to learn. And then here, this is kind of the thing. So I think my name is like Dr. Gold, and then I think this is my passcode. Oh, there we go. Cool, nice. So yeah, so this is example. This is like geometry, and with this you can go to different, like nodes and stuff, and I don't know, like here's like shapes, and then like, oh, with shape there's like 2D figures and 3D figures, and then here's information here. Like, oh, within 2D figures, what do we got? Oh, we got polygons and we got curve shapes. Oh, if I go to polygons, what do we got? We got triangles, quadrilaterals, and it's a mind map. Exactly, yeah, it's a mind map. But it's a cool way to learn things, I guess. Well, that's for you guys to tell us and tell him how you guys like it and if you think it's cool. So it's gonna be very easy. You just basically, you're gonna sign up for this platform. You answer like a quick like survey, and then there's some tasks to like try to go through it and learn things, and then afterwards you do an exit survey, and then everyone who does it, I think we're gonna leave it open for like 3 weeks, but everyone who does it gets entered into a raffle, and then we're gonna raffle off some gift cards and prizes. So rewards for you guys. Anyways, cool. I'll make a more formal announcement about that on the server today. So yeah, if you're viewing us from other platforms and you haven't joined yet, yeah, go check out our Discord. If you click that website, actualdiscord.com/submit, it'll also show you a link to the Discord, so you can get involved with it. Okay, cool. Why am I losing frames now? My internet. Okay, one sec. I'm gonna cancel this real quick. Cancel Discord streaming. Okay. All right, that being said, any other questions and stuff, please feel free to let me know in the chat. I see we already got some questions that people have submitted online, so let's start getting through them, and let's begin. Welcome everyone to Office Hours. My name is Dr. Gold, Actual Education. The stream is helping with math, homework, science, homework.
Nice.
all sorts of fun stuff. Average Twitch behavior. Yeah, I don't know why it just drops frames randomly. But it says we're okay now, so yeah. Okay, we got some screenshots in here. Equity's got some good questions coming up. And then here, let me see if I can share my screen again, Sarah, for you. I hope I can. No, now it's getting mad and it's dropping the frames again. Okay, we can't do it. Can't do it on Discord. Discord also doesn't like really compress their stuff pretty well. Okay, here's a good question. From Equity. Okay. Says, the graph indicates a point in the complex plane. Okay, cool. This is like a good pre-calc topic. Okay. The complex number has polar coordinates r comma theta. Which of the following completes the expression in polar form? 4 square root of 2 cosine theta plus I 4 square root of 2 sine theta. And they want to know what theta is. Okay. Yeah, so a lot of this is the imaginary plane, right? So this is I, and then this is the real plane, which is like R. So usually how we write complex numbers is going to be in the form A plus B times I is what it'll be. Okay. Where this right here is going to be the imaginary, and this is going to be the real. So our point is over here, all right, which means it's somewhere. This is actually interesting because this uses two different concepts. Because we gotta go all the way over here. Okay. So if I wanted to write this, this looks like it's located -4. Yeah, watch on YouTube if it's smoother. I don't know what fucking Twitch is doing these days. I can try one sec. I can try stopping this stream and having it one sec. Let me Twitch. Now let me start this. One sec. I think this should be working well. It's just gonna make me like match the shapes or something. It always does this. Like, please match the shapes. Oh, okay. Well, I think it's loading. Okay. Cool. Oh, I don't have to match shapes. Okay, nice. Here we are. I think that works. Yeah, cool. All right. So this is located -4 on the real side, okay? So here I know that A is equal to -4 because we're going 4 this way. And then it's located up +4. That's a good question. I stream on multiple platforms, but it's only Twitch that apparently has a problem sometimes. So I don't know. It's like Twitch is like hungry for bandwidth and decides to just drop frames instead of just producing the video I want. Okay. So to the left 4, up 4. So I know my number needs to be 4. Sorry, -4 plus 4i. Okay. But instead, they've put it into polar form. Okay. So now we have something that's in the imaginary plane, but now is also in polar coordinates. So that means I need an angle here, which is going to be theta. And then I also need a radius. I need like the length of this. Okay. So the cool thing is, I know if it's 4 this way and 4 this way, we can figure out the radius by just doing the Pythagorean theorem. So I'm going to do 4 squared. 4 squared plus 4 squared is equal to like r squared. And so that's going to get me 32 is equal to r squared. So r is equal to the square root of 32, which 216, 4 comma 4 is the same thing as 4 root 2. Which is good. That's what we saw here, right? 4 root 2. Okay. That's important. We like that. Okay. Now I just need the angle here. Okay. Which, if this is 4 and 4, this is an isosceles triangle, which tells me that this right here must be 45 degrees. So this here must be 135 degrees. But they don't want it in degrees. They want it in radians. Okay. So you can either convert it manually, right? So if I want to do 135 degrees, I multiply that by... What's up, Dr. Pickle Juice? 180 over pi. And then this is going to get you 3 over 4 pi. Right, which is this answer. Cool. And that makes sense here, okay? Because in polar form, right, x is equal to r cosine theta, and y is equal to r sine theta. And so the radius we figured out was 4 root 2. And then cosine, the angle there, cosine of theta, that's 3 pi over 4. So that's cosine of 3 pi over 4. Which, watch what happens. The cosine of 3 pi over 4, you should know this from the unit circle. Cosine of 3 pi over 4 is equal to negative root 2 over 2. And so if we were to plug that into here, I get 4 root 2 times negative root 2 over 2. Root 2 times root 2 is just going to be 2. So then we have 4 times 2 over 2. This cancels. There's and then we get that x is equal to negative 4. Which is what we had originally, right? We had this being equal to the x coordinate was negative 4. So that's how you can double check. And that works out. Nice. So same thing here. They're saying point A has polar coordinates 4, 7 pi over 6. So this is r. This is theta. And they say, what gives the location of A the same location? Oh, okay, cool. So let's try to like graph like where this is, right? So 7 pi over 6. So I know 6 pi over 6. That's a full pi, right? That's going this way. So I need to go an extra pi over 6. So in reality, we're just like right here. And this is going to be pi over 6. Okay. So that's to get to 7 pi over 6. So this would be 7 pi over 6. So maybe let's see what would happen if I went backwards. Like, what would I need to do to do negative angles? All right. Well, that means this would end up having to be 5 pi over 6. Okay. Because you need yeah, x plus or minus 2 pi. Basic. That's the other way you can do this, Jeff. Yeah. That's the easier way. So yeah, anytime you have an angle, you can just do plus or minus various multiples of 2 pi, which 2 pi is the same thing as 12 pi over 6. So if I subtract that, 7 pi over 6 minus 12 pi over 6, that gets me the minus 5 pi over 6. Which is cool. This one works. Yeah. The other way you could have done this, if you wanted to, is you could have gotten this angle if it was right here and also pi over 6. And then if r was negative, that turns it from pointing this way to pointing the opposite direction. So that's another way to do it. You could have done, it could have been pi over 6 and negative 4 for the radius. That would have worked as well. Does that make sense, Equity? And are these AP pre-calc questions that you have to do? What if they are? Okay. Let's see. We got some other good screenshots. Dr. Pickle Juice has a question. I'm trying to read this, Dr. Pickle Juice. A little difficult. Let me see. Let's see if we can show you like what you have. Yeah, this. V sec 2 cosec 4x plus. This is really straining my ability to read this. Yeah. Okay. Let's try to do this question though. I think this. So Dr. Pickle Juice, can you like write a little bit more legibly, like what your question is? It's kind of hard for me to read that.
You done messed up, AA Ron!
Ooh, nice. Anton's got a good one. I like that, Anton. All right, we'll do that question next. Let me see this one real quick. The figure shows a circle radius 4 with 5 labeled points. The measure of DOC is 2 pi over 3. Okay, so DOC, that tells me this is 2 pi over 3. The measure of AOB is half of AOC. Okay, cool. So we know that this and this must be the same, right? Because AOB is half of AOC. What are the coordinate points of B? Okay. Well, I know that the whole angle here, to go all the way across, that has to be equal to pi, right? So let's call this variable here x. Let's just call it x, okay? I know that 2 pi over 3 plus x, so plus 2x, has to be equal to pi. So we can solve for x now, right? Because pi is the same thing as 3 pi over 3. So subtracting that, that's going to get me that 2x is equal to a single pi over 3. And then we're going to divide by 2. And so we get x is equal to pi over 6. Okay, so once we have that, okay, now I can go back and try to get the coordinate points for B, right? So B is going to be 2 pi over 3 plus an additional pi over 6, okay? So that's 4 pi over 6 plus 1 pi over 6. So that's going to be 5 pi over 6. So we got 4 pi over 6 plus pi over 6 gets me 5 pi over 6. And this is the angle, okay? Which were all the answer choices. Thanks. Fun. Okay. So what are the coordinate points? Oh, and then we know that the radius here is 4. Yeah. Okay. So I believe it's just going to be B here, because it's always just r cosine theta, and then it's just r sine theta. You could be tempted to put like the minus sign there, but cosine of 5 pi over 6 is already going to get you a negative sign. So you'll be okay. Anyways. Okay, so cool. Not bad. All right, let's see this one right here. This was a good question that Anton gave. And then Dr. Pickle Juice, I'll do yours, and then Adarsh all yours. I see everyone else who submitted ones. Good. Ooh, some real fun ones here. Okay. Let's see. Anton said, consider two objects with M1 is greater than M2 connected by a light string that passes over the pulley having a moment of inertia I. The string does not slip, okay? The pulley turns without friction. The two objects are separated by a vertical distance of 2h. Use the principle of conservation of energy to find the translational speeds of the objects as they pass each other. Wow. Find the angular speed of the pulley at this time. Interesting. Okay. So, okay, conservation of energy means that we need to state what all the energies are at a certain point in time, and then have it equal to all the energies at another point in time. Okay. So I'm going to remember that we have gravitational potential energy, kinetic potential energy, and then we're also going to have rotational kinetic energy from this thing spinning. Okay. So let's in order to do this, I need to define like where height is equal to 0. So what I'm going to do is I'm going to call this thing right here. I'm going to call this distance right here as h is equal to 0, or you know, right here, whatever. Okay, so if that height there is equal to 0, let's write out the energy first here. So before. So they're released from rest. So because they say everything's at rest, so before we know like everything is at rest. So the kinetic energy of everything is just equal to 0. Because kinetic energy is always 1/2 mv squared, velocity squared. Okay, but let's look at the potential energy. So we do have some potential energies. So this potential energy is 0 because its height is 0. This one, however, you have m1g times 2h. That's the potential energy of this. And now we're done. Okay. So now let's do the after case. So afterwards, okay, now, here, let me just copy this in. Now if we have that M1, for instance, has fallen down a little bit, and M2 has gone up a little bit, but they're at the same height, right? Because we say as they pass each other. So here's what happens. So I now have M1 and M2 at the same height. And then, here, let's take all this. This is h equals 0. Okay, so if, for instance, in this system, this is going to fall down and then this is going to go up, when they pass each other, they must have moved the same amount of distance, and they must be at the same height. So this will have moved a distance h down, and this will have moved a distance h up, so that they are equal both at height h. And because they're connected by a rope, that means they each have to move the same amount. So if this moves a meter down, this has to move a meter up. So if this moves h down to get to the height h, this also moves h up to get up to the height h. Is it correct to say that gravity does work on M1? It does. Gravity does positive work for sure. But it also does negative work on M2. So we're going to say that both of these are now at height h. Okay? And so they're moving, right? So they are moving at some velocity. This is moving at some velocity. And even more so, this pulley is moving with some velocity as well. Okay? So this is moving at some omega here. All right, so we got a bunch of different things here. We got to kind of like try to take into account. Okay, so afterwards, we'll get to the kinetic energy. Let's do the potential energy. So the potential energy is going to equal to M1 GH plus M2 GH. Because you have both of these things are located now at a height h, and they're going to have gravitational potential energy. Kinetic energy. All right, let's look at what we got for KE. All right, so in terms of KE, I have 1/2 mv1, so 1/2 m1. Technically, this would be v1 squared, but I'm just going to say v squared. The reason why is because whatever velocity this thing is moving down will be the same velocity this thing is moving up. So this kinetic energy is 1/2 mv squared, where this one is going to be 1/2 m2 v squared. And that takes care of the kinetic energy for both of these blocks. But now I also need the kinetic energy of this disk, which is rotating. Okay? So we also have the rotational kinetic energy, which is going to be equal to 1/2 I omega squared. This is rotational kinetic energy. Okay. And then this must also all equal this. Okay. And what they wanted us to do was find the translational speeds of the objects. Okay, cool. Well, what I can do is set my total energy before equal to my total energy afterwards. So before, we only have m1g times 2h. So here. So before equals after. And here's a key thing. Do they give us... They don't give us any sort of numbers. Okay. So I guess we're just going to do it all in terms of variables. That's okay. So before, we just have this. So this is 2m1gh. Has to be equal to all this stuff afterwards. Okay. So I'm going to combine some like terms here, because these both have gh on them. So I'm going to say this is m1 plus m2 gh plus m1 plus m2. And then that's 1/2 v squared. And then we have plus 1/2 I omega squared. Okay, they do give us I, but we're not given omega. So 1/2 I omega squared. Now, here's the cool thing about omega is the angular speed at which this thing like rotates around is related to the linear speed that the rope moves as these things are like, you know, going up and down. And the relationship for that is that V is equal to R omega. So omega is the same thing as V over R, where R here is this radius. Yeah, Kevin. Yeah. Try what we're getting like some frame drop issues, so I'm not streaming it to Discord right now, but you can see it on any of the Twitch, YouTube, or TikTok. Either one of those is running. Okay. So omega is V over R. So now I can plug that into here. So I can say, oh, well, omega is equal to V over R. So this is going to be replaced with V squared over R squared. Okay, cool. All right, let's see if some stuff kind of turns out nice. So these are some common terms on this, right? So really we have 2m1gh is equal to m1 plus m2. And then it's gh plus 1/2 v squared. I'm just factoring this whole thing out of both of them. And then we have plus 1/2 1/2, what's that? 1/2 I v squared over R squared. Okay. Oh, this is kind of messy because I got to solve for V. Just solving for V, which is in two different places. Oh man, that's ugly. Okay, so then let me not group this yet. I need to not group this yet. I was getting a little excited because I saw, oh wow, M1, M2, M1, M2. Yeah, but no. We gotta group this first. So here, we got M1 plus M2. Well, here, let me pull the V squared out of both of these. Okay. This is V squared, and then it's 1/2 M1 plus M2. So that pulls that out of this. And then plus 1/2 I over R squared. Okay, there we go. All right. Plus, okay, and this is equal to M1 plus M2. And this is GH. Wow. Cool. Okay, fine. So, subtracting this over, 2m1gh minus m1 plus m2gh. Oh, we can group the GHs. So that's 2m1 minus m1. So that's just going to be a single m1. Okay, so that's m1 plus m2 GH. And then divided by this huge fucking mess, which is going to be 1/2. And then that's going to be m1 plus m2 plus I over r squared. Okay, cool. And then this is equal to v squared. Cool. Okay, cool. What's up, Femvox?
My man.
So yeah, so that's your answer for getting v. Just take the square root, whatever. It's so lengthy to do this. It's such a pain. But that's how you get to it. And then to find the angular speed of the pulley, well, that's easy. Because v is equal to r omega. So angular speed just equals whatever you get for v, and then just divide it by r. And then you should be good. Sorry, this is r squared. Yeah. Okay, cool. All right, good question, Anton. That was kind of a lengthy one, but I hope it made some sense to you.
Good job.
Mechanics, yeah, mechanics is cool, man. I like mechanics. Okay, Dr. Pickle Juice, what was your question? Let's see. So Dr. Pickle Juice he said 4x squared plus 7x minus 2 is equal to 0. Is this what you're solving for? So what I like to do is like multiply these two things together. So 4 times minus 2, and that gets me minus 8. And then I need factors of minus 8, Dr. Pickle Juice, that add up to 7. Okay? So that could be 1 and minus 8. That could be like 2 and minus 4. And that's about it. So 1 and minus 8 work, but also minus 1 and positive 8 work. And this is the one you want. You want this one. Because these two things multiply to negative 8, but negative 1 plus 8 adds up to 7. Okay? So now what you're left with is this. 4x squared. And then you take whatever these are, and you're going to say like minus 1x plus 8x, and then minus 2 equals 0. Does that make sense so far? And now all that's left to do is you have to group things. So I have to now look at, for instance, this and see what I can pull out of both. So out of this thing, I can pull out at least an x. That's the highest x I can pull out, and that's about it. So I'm going to say, okay, I can pull out x. And what that leaves me with is a 4x here and a minus 1. Okay? Then here, all I can do is pull out a 2. So I'm going to pull a 2 out, and that's going to give me 4x minus 1, okay? Now here's the cool thing, right? See how we have the same factor in two places? Okay? So if, for instance, I have like a times b plus c times b, this is the same thing as a plus c times b, right? You know, you can pull the b out of both of them. So we're going to do the same thing here. I'm going to pull this 4x minus 1 from both of these things. And that's going to leave me with x plus 2. And then what's left here on the outside is going to be 4x minus 1. Okay? Which you can then now solve for Because you just solve, okay, when does this one equal 0? Well, that's when x equals -2. Where does this one equal 0? Well, you could write it out if you wanted to. It's totally okay. You can say, oh, 4x minus 1 equals 0. Plus 1 plus 1. 4x equals 1. So then I get x is equal to 1/4. And then that's your two answers. X equals 1/4 or x equals -2. That's one way to do it. If that makes sense. I can show you another way if that doesn't make sense. It's kind of using like a Punnett square. I like it better. I'm a big fan of Punnett squares. I think they're very cool. But let's say, for instance, let me just show you real quick what you could do if you wanted to do a Punnett square. You still have to get to this step, okay? But then all you do is you put this thing on the top left. So this ends up being like 4x squared over here. You put this thing on the bottom right. So that's going to be -2. And then you have this minus 1x. What's up, Zach? Good to see you. I had a lot of fun playing that 16 game. Did we play it over the... I think we played it again over the weekend, didn't we? I remember I played it with you on Friday for sure. And oh, I was so close. I now understand how the betting system works at the end. I was a little confused at first. I thought the multiplier was that you could lose it. You could lose it as well as gain it. But now that I know you can only gain, I'm gonna bet everything. Well, that was fun. I had a good time playing this. But Pickle Juice, all you gotta do is you see like, oh, what can I pull out of here, right? Well, out of both these, I can pull a 4x out. And then you ask yourself, okay, well, 4x times what gets me 4x squared? And now it's just a puzzle. This is x. Okay, so then you're like, x times what gets me -1x? All right, cool, that's -1. 4x times what gets me 8x? Oh, that's 2. And now you're left with the answers as well, which would, these just like come out. And this is just x plus 2. And then this comes out, and this is just 4x minus 1. Yes. Nice. Good job, Pickle Juice. Oh, let me give Equity his coin.
Well done! Well done!
Okay, yeah, go get your logarithm questions. We'll do some logarithms. Nice. Shantrick is back. Okay, cool. Adarsh, are you around? Can I help you out with yours, Adarsh? Has Twitch started like chilling out a little bit? Are we not dropping as many frames on Twitch anymore? I don't know why it just does that. It just gets mad at me sometimes. We'll see if Adarsh is around for this. Hello, are you a math teacher? I do teach math. Does that qualify me to be a math teacher? I'm not a certified. I don't have a teaching certificate, but I've taught a lot of math. I don't know. Does that count? Adar says number 29. Yeah. Okay. Cool. We can help you. Number 29. Yeah. Welcome, Peter. Peter, if you have any questions in math or science, you can ask them here, and we'll do them for you. Bonafide math teacher. I appreciate that, Zach. Okay. A triangle has lengths 4.7 and 9 meters. Which of the following cannot be the length of the third side in meters? Okay. So this is called the triangle inequality, I believe. And what it says is the sum of any two sides has to be bigger than the third side. Okay. So sum of two sides. Good. Oh, Peter says, you're a teacher too. I'm from China. Oh, welcome. Congratulations on us recently getting rid of our tariffs temporarily. What the fuck Trump is doing half the time. But apparently we're now friendly for trading again. Which I appreciate because I buy so much gold clothing from AliExpress. And it was going to get really difficult for me to import stuff. Alright, sum of two sides has to be bigger than the third side. Okay. So let's check, for instance, let's check 5, for instance. So if we had 5, right, as one of our sides, well, 5 plus 4.7 is equal to 9.7. So that's greater than 9. So that's okay. Okay. And then also 5 plus 9 is equal to 14, which is greater than 4.7. So you're okay. So yeah, skip ahead all the way down to E. So this should, once you see that this works, maybe like try to go like, and you know, as like a test taking strategy, go look at like one of the bigger numbers and just check it out. Okay. So let's see why 14 does not work. Okay. So if one of the sides is 14, so that you have 4.7, 9, and 14, here's the issue. If we add these two together, that's 13.7. But 13.7 is shorter than the other side 14. So this one does not work.
No.
So you can't do this. So this is the cannot, and that's the correct answer. I don't know, like a, you know, logical way to do this other than to just like check numbers. I mean, I would check the smallest number and I would check the highest number, because that's what's most likely to cause you problems. You're either like, for instance, let's say that one of the answer choices here was like 3, then that would not work, because 3 plus 4.7 only gives you 7.7, which you can't have, because that's smaller than 9. So logical is that it has to be the highest. Well, and as we showed here though, Shantrix, it could be the lowest. Why can't the sum of two sides be smaller than the third? That's a good question. Why can't it? I want to say it's something with like the distance formula or something. No, there should be a well, let's look this up, actually. I'm curious. Well, did any of my resident math people here already know what it is? I mean, I can go look it up. Why is a triangle inequality? Just why? Just why is? This is because the straight line between 2 points is the shortest distance, and therefore any detour through a third point will be longer. Okay, very cool. Jeff says, draw the third side, then 2 circles for the other 2 sides. Oh, draw the longest side. Okay. So this is what Jeff is saying. He's saying that if, for instance, we had the longest side. Let's say this was the longest side, C. Okay. Then 2 circles for the other 2. Well, let's not do that. That's too big. You're saying like this. Like, let's say this was another side, right? So I don't know, you want to call this like A? And then what? Are we going to call this like, I got to make it like the right size, right? It's kind of hard. Okay. I think that looks pretty good. We're going to call this like B. I think what he's saying is that, right, the shortest, right, if they don't touch, there's no triangle. Yeah. Okay. So if you're going, for instance, between point 1 and point 2 here, the shortest distance between those 2 points is straight through them, right? So if you add a third point on a triangle, right, this has to be a longer distance than this. You have to have 2 of the sides sum to something bigger than the third side. Otherwise, it's impossible. Like if this is, let's say this was like slightly shorter, okay? Well, now, yeah, let's say we did this. Now this can't form a triangle because there's no way for this to connect to this side, if that makes sense. You see that, Dylan? Like, yes, now technically, right? You know, A and B add up to something that is shorter than C, but that creates a problem because there's no way for us to form a triangle with that. Yeah. So that's cool. That's cool. That's a good like graphical description of why the triangle inequality is what it is. I like that, Jeff. Jeff loves his circles. Very good with the circles, Jeff. Would A plus B equal C if we go infinitely close? Oh. Well, yeah, but then that's no longer a triangle. That's just a line. Bro, you still haven't shaved your beard. I did. It is shorter. I have shortened it a little bit. It is a little bit shorter. That's called a degenerate triangle. Yeah. Infinite triangles. Okay. Cool. That's a good question, Adarsh. Kevin is preparing for his 5th online 8-week course with 4 credits. Wow, that sounds scary. What course is that for, Kevin? And who is this? This was Adarsh. What's up, Cuber? Let's see if I can stream again to Discord. I don't know. Y'all tell me on Twitch if things start breaking. Tell me if it starts getting mad again. I hope it doesn't. Dun, dun, dun. Ooh, okay. Good questions here, Cuber. Nice. You want me to help you with these, Cuber? And then Chantrix will do yours, because I don't think yours should be too bad. Yeah, sure. Okay, here. All right, cool. You have your test on Wednesday? All right, cool. Dub, let's help you out. How was my trip to the dentist? I mean, my teeth feel cleaner, I guess. But they were saying that I need, like, crowns. I'm like, fuck, that's about to get expensive. Don't do that to me, man. So I gotta go tomorrow for the gum specialist, apparently. I don't know, I'm not looking forward to it. You're having such a sharp jawline. It would look so cool after being clean shaved. Yeah, see, Gmail user, the only reason I appear to have a sharp jawline is because of my beard. If I don't have my beard, I guarantee you I don't have a sharp jawline. It's primarily the beard that does the work there. Anyways, okay. Let's try to do this one. Okay. So, Cuber, whenever you have, like, exponents to an exponent, you see how these two things are being raised? Nice, Pickle. Yeah, we'll get to that. Raised to this one. You're going to distribute this exponent to everything. Oh, it is not on the screen. Sorry, my bad. Thank you. Okay. Do you see this, Cuber? It's a good beard. Don't shave it. Yeah, please no. Yeah, don't. They take forever to grow. Okay. So, whenever you have exponents and they're all being raised to another exponent, this has to go through and multiply each one. Also, technically, this has an exponent on it. It's not seen, but this is also 3 to the first. Okay? So, when I take this exponent and raise everything, I have to multiply the exponents. So this, what's up, Famished?
My man.
So this is 3 to the 1 times 2. So that's 3 to the 2. This is x to the 6 times 2. That's x to the 12th. And then this is y to the 4 times 2. This is y to the 8th. And then we still have this. And actually, just quick hint here, right? X to the 0 is the same thing as just 1. Okay, so it's just 2 times, it's just 2. Yeah. I struggled for a very long time with these two, Famished, honestly. It's hard to remember, like, which rule is which. I have to always, like, create dummy cases for myself and then just test them out. Just make sure you don't use 2 as your dummy case. Because 2 plus 2 and 2 times 2 and 2 to the 2 are all the same number. So it really fucks things up. Okay. So now once you have things multiplying here, okay? This is a cool thing. Does the 2 not go? Yeah, watch. So all of these things are multiplying. You can change the order of them. So what I'm going to do is I'm going to take the 3 squared and I'm going to put it out front here with the 2, right? So I'm going to say, oh, this is the same thing as 2 times 3 squared. And then we're going to group that one back there. And then we're going to say times x to the 12th times y to the 7th times y to the 8th. Okay. Shantrix. Oh, I fucking love that, dude.
My man.
That's hilarious. This is now Cuber. Anytime you have if you have the same base but different exponents and they're multiplying, you add the exponents. So this is y to the 15th. This is x to the 12th. 3 to the 2 is 9, and 9 times 2 is 18. So then this is your final answer here. Does that make sense, Cuber? Yes. Okay, cool. All right, nice. Okay, so then let's look at this one. So this is the same thing. You just subtract the exponents. So x to the 3 over x to the 9th. That's x to the 3 minus 9, which is x to the negative 6th. Okay. And then this is y to the 8th minus 12. So that's y to the negative 4. And then 4 over 24. Well, that's the same thing as 1 over 6. Okay. So what you have is now 1 over 6, x to the negative 6th, y to the negative 4. But negative exponents go on the bottom with positive exponents. So this is 1 over 6, x to the 6th, y to the 4th. You could have also just thought of like, this goes away, and then this is a 6, this goes away, and then this is a 4, and then this is 1, and then this is 6. That's another way to do it. But sometimes it, you know, it gets a little tricky to see things, and so it's easier to just write them this way. Does it? Okay, and this is a beautiful example of why, okay? Because I don't know, seeing like -3 and then -7, this is just really odd. Okay, I don't like this. So here, I'm going to write this as like 8 over 32, which is the same thing as 1 over 4. And then here, okay, now I have x to the -3 minus -7. And then this is y to the 5th minus -2. Yeah, I don't do canceling because then my teacher might not count my steps and it can get messy. Exactly, yeah. This is where it kind of gets messy because you have negative exponents on the top and on the bottom, Cuber. So when that happens, I sometimes need to be like, oh, it's -3 minus -7. Minus is the same thing as a plus. So now you have 1/4, and then this is -3 plus 7, which is to the 4. Now this is 5 minus -2. So that's 5 plus 2, so that's 7. So then this is your final answer for this one. It's just a way to, you know, have it make a little bit more sense. Does that make sense, Cuber? And then here I can download these for you so you have them. You think so? Oh, well, we want you to know so, dude. Let me see. There you go. I have videos on these too, if you want, especially because I see your other questions, which if you stay around, I will do these eventually. Just let me get some time to help out the students. But these ones are very important, Cuber, to be able to do these. How come you do that thing on the 17 and the 18 different? What do you mean different? Did I do something different between here and between here? Or are you saying like my two different methods, like how I did it on 17 and how I did it on 18? Like, do you have to simplify 17 like that? You don't have to. I mean, well, you do need to get to here. You do need your answer to be 1 over 6 x to the 6 y to the 4th. This most definitely has to be your final answer. I was just showing that there's a couple ways to do it. So you could have done this as 1/6, and then it was x to the 3 minus 6. and then y to the 8 minus 12, which is then 1/6 x to the -3rd, y to the -4th, and then you convert it back to positive exponents. Or did I fuck that up? Wait. Sorry, it was 3 minus 9, not 6. Is it only because the exponents are negative? Yes, correct. Yeah. Your teacher probably does not want you to have negative exponents. So you almost always got to, like, make them positive. But by the same token, Cuber, if you have, like, for instance, 1 over x to the -4, you need to write this as x to the +4. You have to bring this up and then make the exponent positive. I do have this on YouTube. I for sure have I have a video on this, Cuber, that you should really watch. My channel, 1 sec. And it's like exponents. Yeah. All of these videos. So this one.
Here's the quick way to simplify radicals when there's messy variables in x.
So this is like simplifying radicals. This is exactly what you're doing. You're doing this stuff. And like I have like animations for it. So please watch that one. And then I think this is the other one. Right. And then this has to deal with when exponents are fractions. So both of those videos are very, very, very applicable to what you're doing. So try to check them out. Or if you hang around the stream, I'll get to your other 2 pages of questions. Let me just help out. I got a couple more people. Dun, 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 dun. Okay, I want to do Chantrix's. I really do. Let me do Chantrix's real quick. And then pickle, and then equity, and then... can I copy this image, please? Ooh, okay, here we go. If x and y are positive real numbers with 1 over x plus y equals 1 over x minus 1 over y, what is the value of x over y plus y over x squared? Ooh. This is kind of a fun one. My gut instinct is to try to like multiply this. Or like maybe see if this is something fun. What's x over y plus y over x squared? So that's the same thing as x squared over y squared plus y squared over x squared plus 2 times this, right? So plus 2x over y times y over x. Well, that's cool because this goes away. That's just 1. Right, Chantrix? So I get this is the same thing as x squared plus y squared. Well, okay. X squared over y squared plus y squared over x squared. Huh. Okay. So I want to know what the value of this is, which this kind of like almost, no, because it's not a difference of squares, right? It's a sum of squares. Okay, I mean, that's cool. Let me see what this is. So 1 over x minus 1 over y, if I make them common denominators, that's the same thing as y minus x over xy. My thought would be u equals xy and rewrite everything in terms of u. Okay, but how do you justify then this, Jeff? How are we going to write this in terms of u? Decompose it. Okay. What would you decompose? Because, like, I want this to turn into this somehow. Which, okay, so... is that x squared, y squared? Wait, no. That's x to the 4th plus y to the 4th over x squared, y squared. Yeah, it almost looks like, what's that called? Partial, like decomposition? Partial fractions? So he says if u equals x over y, then x equals u times y. Okay, all right. Let's try. I'm gonna take the Jeff intuition here. Let's see what we get. Yeah, maybe. You really like the ad about physics? Cool. Thanks, Dr. Pickle Juice. Okay, let's say for instance that x over y is equal to u. Okay. Then y over x is equal to 1 over u. Sure. So we want to know u plus 1 over u squared equals what? Right? Okay. All right. So x equals uy. So what, you want to like let's like rewrite this then? So 1 over uy plus y equals 1 over uy minus 1 over y. I have no idea what I'm doing, by the way. No, that's cool. I kind of see it. So this is the same thing as... one minus u over uy. Multiply both sides by ui on this side. You want me to multiply both sides by ui on this one? I just combine them. Okay, let's try it. All right, Jeff says, inspiration here. Let's multiply this all by ui. Let's multiply all this by ui. Let's just see what we get. Okay. So that gets me ui. Ah, the golden ratio. Is that what this is? Is this the golden ratio? Okay, and then what? This is equal to... well, it kind of looks like golden ratio, right? Isn't the golden ratio 1 minus 1 over x? Yeah. So that's 1 minus u. Right? No, it's cool. I'm trying to think what I do with this, though. Ooh, what if we invert both sides here? Let's invert. Watch. Invert. So then I get uy plus y over uy is equal to 1 over 1 minus u. So this is, look at this. This is 1 plus 1 over u is equal to 1 over 1 minus u. Right? Okay, and now this is solvable. Or actually, I could have just divided by u everywhere here. I was being really dumb. Okay. So, yeah, should I solve for this? I feel like I should. Am I just gonna get 1 equals 1 though? If I do this? I don't know. So actually, let's start with this. Sorry. So I have u over u plus 1 is equal to 1 minus u. If I multiply through, I get u. Okay, here we go. U is equal to 1 squared minus u squared. Right? Okay. So then I get u squared plus u minus 1 equals 0. Right? Which, what multiplies to 1, multiplies to -1 but adds to 1. I don't think that's anything nice, no? Yeah, 1 minus, oh. Okay. So, yeah. Square root of 5. So x equals -1 plus minus square root b squared minus 4ac all over 2. So that's -1 plus or minus the square root of 5 all over 2 is equal to u. That's not very nice, is it? Invert and add, okay. And then square. Yeah, I think so as well. I wanted to maybe prove why that was. Okay. Alright, alright. Also, like... Yo, what's up, Taco? Yo, happy birthday, Taco, by the way. Big happy birthday to you, Taco. What'd you do for your birthday? Anything fun? You get some awesome gifts? Yeah, what better birthday present, Taco Cat, than a 20 stream streak on our stream? Quadratic. Hello, Dr. Gold Sir. What's up, Shari? Does it matter which one I use? Jeff? I feel like I can just like use it or like whatever. Fuck it. I don't care. Alright. We're just gonna use the positive one. -1. I appreciate that, dude. Thank you, Taco. Okay, let's just do it. Fuck it, we're doing it live. This is so gross. So gross. So this is, if I want to combine these, right? That's 1 plus the square root of 5, -1 plus the square root of 5 squared, plus 4 all over 2 times -1 plus the square root of 5. life. I want to know, Femvox, how you got this without, like, this messy mess that we have. Okay, so this is 1 plus 2 root 5 plus 5 plus 4 all over negative 2 plus 2 root 5. So, okay, what's that? 5 plus 4 is 9. 9 plus 1 is 10. So we have 10 plus 2 root 5 all over negative 2 plus 2 root 5. I can divide everything by 2. So that's 5 plus root 5 all over negative 1 plus root 5. Multiply through by negative 1 minus root 5. Negative 1 minus root 5. And then I get minus 5 root 5 minus root 5 minus 5 all over 1 minus 5. You did the same thing I'm doing? Okay. So that's negative 10 minus 6 root 5 all over negative 4. Wait, and then I have to square all this, don't I? This is such a lengthy question. Okay, whatever. There's negatives everywhere, right? So that's 10 plus 6. All right, and then let's divide by 2. Okay, so that's 5 plus 3 root 5 all over 2. And then we got to square that. So now that's 25 plus 30 root 5 plus 45 all over 4. 70 plus 30 root 5 all over 4. Divide by 2. 35 plus 15 root 5 all over 2. That seems really messy. Is that the correct answer? I really don't want to do that. The answer is 5. Well, fuck me. It says the answer is 5, by the way. Oh, the algebra here is killing me, dude.
Surprise, motherfucker.
Yeah. It's really messy. No Ronaldo. The solution is very elegant. I'm sure it is. This is like ugly. Ugly as sin, dude. Yeah, maybe I could have. Yeah, what's up, Anders? What's going on, dude? You lost a negative when you squared the negative 1 plus square root of 5. Ooh, did I? I did. Thank you. Good catch here. Yeah, I lost this negative. We were meant to be so much more. Okay. Okay, so this is minus. We were meant to live for so much more, and we lost ourselves. Okay, I think this is it. Oh. Oh. Yes, I see it right here. I see it right here. Fuck all this. We don't need any of this. Okay. Right here, we're good, right? Because this is the same thing as 5 minus root 5 all over negative. No, shit. Negative 1. Yes, negative 1 minus root 5. No. Ugh. Factor square root of 5 on the top. I just finished a 24-hour take-home final exam E&M and my brain doesn't want to process these numbers anymore. Oh no, dude. Oh dear. Good to see you, Laz, dude. Okay, he says fact out of root 5. Wait, how am I gonna do that? Am I gonna say this is root 5 squared minus root 5? All over what? Wait, how do you factor square root of 5 from the top? Oh. Wait, square root of 5. Oh, I see what you're saying. Square root of 5 minus 1 all over -1 plus the square root of 5. Very cool. Okay. This and this are opposites of each other, right? Or they're the same thing. This is square root of 5 minus 1. Oh, very cool. Thank you, Fembox. This goes away. Okay. Square root of 5 squared equals 5. Beautiful. Oh, we did it. Yes. So happy. Nice. Okay, cool. Loki says, yes. Why did we not just multiply by the conjugate? We could have. Totally could have. This is just a very... This is a very clever trick. That's very beautiful. Yeah. So we got to here. So you're right. I could have done this, by the way. Yeah. Good question from... who was that? From Loki. Yeah, Loki was asking, well, we could have rationalized. But I'll just show you why it's like... It's just so much uglier. Because now I'd have to multiply this by -1 minus the square root of 5. And then this would be over, right? This would be -1 squared minus the square root of 5 squared. Yeah. So the bottom becomes 1 minus 5, which is -4, I guess, right? So this is -4 on the bottom. Because this is 1, and then this is 5. And then this becomes -5 minus 5 root 5 plus root 5 plus 5. So then this goes away, this goes away. -5 root 5 plus root 5, so that's -4 root 5 over -4. This cancels. Good, you get square root of 5 again, and then you can square that and you get to 5. Because, yeah, at the end of the day, we wanted u squared. Well, yeah. Yeah, I was just combining these first. And then we needed to square it eventually. Okay, cool. Wow, that's a cool question there, Shantrix. I was getting very mad at all the algebra. But all good. Dylan and Dr. Pickle, we got questions from. Dr. Pickle, you still around? Gold, I have a question about physics vocabulary. Please. What's the question, dude? Let's see who else we got. Dry Nose is always putting these fun ones in here. Dry Nose. When you learned GR, did you use the term covector? So you're assuming I learned general relativity, which I did not. I did special relativity. General relativity I did not. Yeah. That's more of like a that's a theoretical physics path. I did more like experimental. But GR is cool. My one friend, David Chester, is a QG quantum gravity researcher. Yes, I can, Equity. You tell me, which one did you need help with? Sorry, was it this one, or is it both of them? And then also, someone has this question, and they submitted, and then this is Dr. Pickle. I'll do Dr. Pickle Juice real quick, because this one's easy. Monads? Sounds like gonads, dude. Alright, one sec. The log of z squared over x to the fourth. It's the same thing as the log of z squared minus the log of x to the fourth. And then this is the same thing as 2 log z minus, and then this exponent comes down, minus 4 log x. That's how to do that one. And then let me see this one, equity, and then I'll do yours, equity. This one came from another person who submitted one. Oh, who's putting the fucking Facebook soccer mom? I think it's literally a soccer mom at this point. Okay, let's see if we can do this one real quick. I think this one came from Dylan. Said a function is defined on all positive integers such that f of x times y. Yes, I know that question. A plus b equals 1. A squared plus b squared equals 3. What's a to the 8th plus b to the 8th? Yeah. I think we can do that one. Yeah. fxy is equal to f of x plus f of y for all x and y. It is known that f of 10 and f of 10 equals 14. F of 40 equals 20. Oh, okay. What is the value of f of 500? I think I have to use like 10 and 40 to somehow get to 500. So answer is always C. Got me through undergraduate work here as well. What's up, high potential? Okay. Well, let's think about this. So 500, you could break up into... I want to do like... Here's what I want to do. I want to do like f of like 10 times 40. Or no, I want to do 10 plus 40. And then I want to do this like times 10. That's like what I want to do to get like f of 500. Question is that like, how do I do the other things? Only because I can rule out the other ones. Average for the class on all finals was a 30%, but it's unrelated. So wait a minute. My brain's like kind of like messing with this. Okay, so like f of 400, right? That's equal to f of 10 times 40, which is the same thing as f of 10 plus f of 40, right? High potential, who is that sweat? He's our favorite NASA sweat. High potential, how's NASA doing with all this like funding crisis shit going on? Are you okay? All my academia friends are like sweating bullets. Apparently like NSF and DOE just like cut everything, dude. Right, here we go. Yeah. So f of 10, right? That was 14. F of 40 was 20. Chaos, I'm pushing on defense. Yeah, there you go. Defense contracts will never cut the black budget, at least.
That's dope.
As long as it's related to defense spending, we're okay. Okay, so f of 400 is equal to 34. Do you have any... Someone asked here on TikTok, do you have any tips for Algebra 1 EOC Minds Tomorrow? What's EOC? Estimation of change? High potential says we lost a quarter. Mars sample return being redemption. Oh no. Don't cancel it. Luckily I'm not doing Mars science anymore. Hypersonic stuff, DARPA. Yeah, there you go. Yeah, DARPA loves cash. Yeah. Oh, end of chapter. Algebra 1 is what you're saying. Well, I love my kitty Katrosi. which that's cool if you got a kitty named Katrosi. If you have like a test review that you have to go through, that's the best way to get prepared for one of your tests is go through like what your teacher's putting on the test review. And if things don't make sense, you can ask questions here and we can go over it. Can you solve integrals? I solve many integrals. I'm trying to figure this out real quick though. So wait, we know f of 400 is equal to 34. Does that eliminate some answers for me? Does that eliminate like A and B at least? Right? Because it looks like it's monotonic. It's increasing, right? So f of 500 has to be greater than f of 400, right? That would make sense. I am also going to try to... I also think it's C. Functions, the Sheridan problem. Low potential Jeff. Oh, I like that. The 654... Yeah, and it's just plus minus or something. Yeah, that's a fun one. Let's get this one. I'm so close to this one. It's only defined in positive integers. Correct. So there's no way to get negative numbers, right? Oh, I think... Oh, right, okay. So f of 1,000, great. That's equal to f of... f of 100 times 10. So that's f of 100 plus f of 10, right? But then f of 100... is equal to f of 10 times 10. So that's equal to f of 10 plus f of 10. Okay. And f of 10 was 14. So f of 100 is 28. And then plus an additional 100. Plus an additional 14. Ah, okay. Very cool. 42. Okay. F of 1,000 is equal to 42. So that nixes this. Okay, answer C.
That's dope.
Could we determine it's exactly 39, or could we just do that through process of elimination? Yeah, that was kind of cool. What's up, Motion? Motion, you asking some interesting questions here, dude. See, it was C. Never fails, dude. C it is. Kind of a fun question though. So f of 2 must be 3. How do we get f of 2 is equal to 3? Motion says, can I be a mod for TikTok now? If I can figure out how do I make you a mod? Can I click on your name here and just make you mod? Oh, here we go. Okay, there you go. I think you're a mod now. You tell me, Motion, if you're a moderator or not. I'm pretty sure I made you a mod. Sir, you did it by gambling. I mean, it worked. Okay. What's up, Equity? You still around? Nice, Motion. Congrats. You are now a moderator for my TikTok channel. All right, Equity, let's do it. Okay, several students' SAT scores are collected and compared to their GPA for the first year. A regression model is calculated. And then here's the residual plot. Very cool. So key thing about residual graphs, you need them to look scattered. If a residual graph looks like it has any sort of pattern, that means you used the wrong model for your fit. Okay. If it looks kind of random and shit, like, you're okay. Oh no, where'd it go? Oh fuck. Did we lose already? Really? One second. I'm gonna go grab it back for you. Sorry, Equity. Please hold. Okay, there we go. Right, now we're back. Okay, the given plot has been labeled at this point P. What does it indicate in the context? Okay. So what that indicates is that, I don't know, this student here who scored a 1050. Oh, wait. Compared to their GPA. And compared to their GPA from their first year of college. Okay. So this person scored 0.63 less on their GPA than they would be expected to for someone with an essay score of 1050. Gambling, process of elimination. So true. Does that make sense? Like the residual here being negative. This is like negative. I think they do this. Okay. So this means for an SAT score of 1050, the student at P had a first year GPA that was 0.633 lower than the model predicted. That's what I would say. Because this is how far off. So, I mean, probably what happened, right, is that the actual graph looks something like this. And then this is like point P here. Let's say this is like SAT. And then this is GPA. So this student should have scored up here if they were like following the model. But they did worse. And that's why this is their residual. I think there's a difference between like explained variation and unexplained variation. You guys don't touch this in A levels, GCSE? I mean, they're cool. Residual plots are cool. Mainly just for seeing whether the model's appropriate or not. That's why I use a residual graph. Okay, the point labeled at Q is this. Okay, so, I mean, this makes sense, equity, right? So I would say for an SAT score of 1420, the student at Q had a first-year GPA that was 0.3 higher than the model predicted. Right? So now Q, our student over here, they had a higher GPA than expected, and that corresponded for an SAT score of 1420. Or instead of saying for an FAT score of, I would say with an SAT score of 1050, then the model predicted for the average student with an SAT score of 1050. Or here, if you want to let's just get rid of this. That's what I'd say. The student at P had a first-year GPA that was 0.63 lower than the model predicted for the average student with an SAT score of 1050. That's, I think, the technical definition that works. You know what? It's funny. 1420. That was my SAT score. I had a 1420. I wonder what it would have predicted my GPA to be. Terrible origin on that graph. Yeah, I know. Here, Jeff. You want me to make it? You want me to make it good for you? I'll do this. Watch this, Jeff. It's gonna blow your mind, dude. Is that cool, Jeff? We cool with that? Have you ever done a stream on fluids or thermo? Yes. Yeah. I answer all sorts of... He said no. Not the wiggly line. Yes, Conjure. I answer all sorts of questions in all sorts of different fields and subjects. So, I mean, that was an example of a statistics question. Earlier today, we did a pretty good kinematics question. This was a fun one. Did this earlier today. It was like a pulley, and with two masses, and then the masses are like moving, and then we want to figure out what's the speed when they're at the same height, and then what's the rotation speed of the pulley. So we did that one. And then we do a lot of math. That's statistics. Okay, here's Equity's other one. Can you explain monads? Am I multi-streaming? I am. So tell me if the Twitch is okay. But yeah, that's all the chats we have. So we have people on a lot of different platforms. I think right now, yeah, we got TikTok, YouTube, and Twitch running. Yeah, rad. Okay, here we go. The functions g and h are given by g of x is log base 2 of x cubed plus log base 4 of x. Can you do the JE advanced? You can ask a question from it. I can definitely try to do it. That's the Indian one everyone always does, right? Ask him any god level questions. He will solve it and give you the answer in the same way. I'm far from God. But I appreciate Shari. Alright, h of x is this garbage. Right? G of x is a single logarithm without any negative exponents in any part of the expression. Okay, cool. Not bad. Okay, so g of x is equal to log base 2 of x cubed plus log base 4 of x. I need these to be the same base, right? How do you do that? I mean, I could do the change of base formula, right? So log base 2 of x cubed, that's the same thing as 3 log base 2 of x. But then log base 4 of x, well, that's the same thing as log base 2 of x. Oh, I got it. Over log base 2 of 4. Got you. Okay, cool. Yeah, so this is the change of base formula. Log base a of b is the same thing as log of b over log of a, where these can now be any new base. And I'm going to choose this to be base 2 because I want this to eventually be also log base 2. Okay. And the log base 2 of 4 is just 2. Right? So this is log base 2 of x over 2. He's so humble. Okay. So, adding this and this, okay? That's the same thing as 3 log base 2 of x plus 1/2 log base 2 of x. So that's equal to 7/2 log base 2 of x. Okay. So this is equal to 7/2 log base 2 of x. Yeah, 3.5. That's also correct. Just don't really like mixed fractions. Okay. Write h of x as a single base with an exponent. Okay. So this is 4 to the x, 4 to the 1, 2 to the x to the 3, I think. 2 to the x to the 3. And then this is all over 2 to the 2x, and then minus 3 means we're going to have a 2 to the 3 up here as well, right? Because 2 to the 2x minus 3 is the same thing as 2 to the 2x over 2 to the 3. And if that's on the denominator, then this goes down here, and then this flips up. I mean, sometimes coders are very like most things, Jeff, if you eventually get like so specialized into a field, it becomes hard for any other field to like assert dominance and hierarchy on knowing things. Because, like, for instance, I mean, some people would argue that a PhD in physics is harder than engineering, right? But I get absolutely stumped when some people bring in like engineering problems and it's like Young's modulus and like coefficient of this and like things get into like these weird like special jargon things that I don't know. If you don't understand it, you're never gonna get it if you've never seen it. Wait, how can you write log with base 4 with log base 2? I can't think of a harder PhD than plasma physics. It sounds hard. It's not that hard. Okay, so watch. So log base 4 of 2. That's the same thing as the log of 2 over the log of 4. All right? And then the cool thing about the change of base formula is you can pick these to be whatever base you want them to be. So I chose them to be base 2. Wait, and it wasn't log base... it was log base 4 of x. Sorry, this was of x. Sorry, my bad. Yeah. So do you see that, Equity? Mathematical philosophy. That's probably a pretty hard PhD, honestly. So this is log base 2 of x over... And the log base 2 of 4 is just 2. Yeah, okay, cool. This is such a pain. Why are we doing this?
Oh no! Oh no! No!
Why? Fine. 4 to the x is the same thing as 2 to the 2 to the x. So it's 2 to the 2x. And that's the same thing as this. 4 is now 2 to the 2. So this is 2 to the 2x. Uh, 2 to the 2. 2 to the 3x. 2 to the 3. Over 2 to the 2x. Oh, look. So these cancel. Oh, Motion, you have like a pretty picture. Like on my screen, your text is like kind of like pinkish. I feel like it's kind of pinkish in the chat. I think it's because you're a mod now. Any tips on getting into garlic and thyme cultivation at undergraduate or bricklaying and banter studies? You know, they actually offer PhDs in like, not PhDs, they offer like undergraduate degrees in wine tasting at some colleges here in California. Okay, but this is 2 to the 3x plus 5. Okay, do we see that? If you're interested in category theory from a coder perspective, I recognize a course by Bartosz Maluski. Oh, that's cool. Do you have a doctorate in any field, or are you naturally a genius? I do have a doctorate in physics. I do. People always ask me, like, is it real? Like, it is. Right. Here, Condra, if you want to go read my thesis, you can go read it. Give you some light reading right now. He's naturally genius and doctorate. I wouldn't say I'm a genius. I do try a lot. I think maybe perseverance is what I would say. I'm very determined. I don't quit. And yeah, so, I mean, some things do come a little bit faster than others would have things come to them, I guess. Okay. Okay, so we did that. Okay, the function k is given by this. Solve k of x is equal to 6. Great, okay. So 6 is equal to 5 plus... I'm going to move the 6 in front. So I'm going to say log base 4 of x to the 6th. Now I'm going to subtract 1. 1 is equal to log base 4 of x to the 6th. So then I'm going to say, okay, cool. In exponential form, 4 to the 1st equals x to the 6th. So x is equal to plus or minus the 6th root of 4. Is that how this works? 4 to the 1/6. Which, I don't know. That's, interestingly enough, though, I'm pretty sure this has to be positive because you can't take the log of a negative number. No. So, I think you just get x is equal to 4 to the 1/6. I'm asking, hey, no, that doesn't work. Screw it. Okay. The function is given m of x is equal to 2 ln of x minus 7 ln of 7x minus 10. Final input values in the domain that must yield a value of 0. Okay, well, you can combine these. This is the same thing as the ln of x squared minus the ln of 7x minus 10. So if you combine that, that's the ln of x squared over 7x minus 10. And the only way for this to equal 0 is to take the ln of 1. So this must all equal to 1. So now you have x squared over 7x minus 10 is equal to 1. Or x squared minus 7x plus 10 is equal to 0. Right? If you multiply this over and then subtract everything over. Okay. So then the factors of this is minus 2 and minus 5. So you get x minus 2, x minus 5. So x equals 2 or 5. So who is Ellen? Ellen who? Ellen who? What? Ellen? Okay, but then you got to check in here to make sure that doesn't make it negative. And so 2 is okay. That's 14 minus 10, great. And then 5 is also okay, because that's 25. Yeah, cool. So there you go. That's how you do those. Equity. Hope that helps.
Well done. Well done.
Nice. Here, I'll download these. Yeah, I will send you the screenshot. I'm gonna dump them in the chat here for you. There you go. Cuber, are you still around, Cuber? Let me know, Cuber, if you still want help with your other ones. I'll do them. Otherwise, I got some fun questions. These are always too funny. People ask these ones. Oh, you have one question. How to get 7/2? Here? So this ended up being 3 log base 2 of x. And this ended up being 1/2 log base 2 of x. So since they're both log base 2s of x's, when you add 3 of them to 1/2 of them, you get 3.5 of them. And 3.5 of them is the same thing as 7/2. 6/2 would be 3. Would not be 3.5. Okay, who asked me this question? Okay. I always feel like this is always like, okay, so x equals 10, right? Oh, yeah, you're welcome, Equity. Look at these sneaky people here. Look what they're doing. Look, they put the whistle on this bitch here, but they didn't put him here. Wow. Sneaky, 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 sneaky. Sneaky, 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 sneaky. Motion, are you smashing that like button? Because we're already up to 1.2k. I see you. I see all these hearts coming up. Okay. Thank you, Motion. Okay, so x is equal to... I was like, dude, how do we go up to like 1.2k likes already? X equals 10. This tells me that this person, right, must be equal to 5, I guess, right? Okay. So then this must be 5. And then each one of these must be 4, right? Okay. But now things get cut in half, so watch. So this right here is a single sneaker. So this is 10 divided by 2. This is the man minus one of his whistles. So minus 4 over 2. That's this. And then this is times a single whistle, which is times 4 over 2. So... Not working? What's not working? Oh, is baby voice not working? What the hell? Oh, I'm sorry. Why is that not working? One sec. What filter is that in? I think that's in my mic. One sec. Here we go. Filters. Oh, you know what? I may need to reconnect. That makes so much sense. Sorry. Yes. Wait. Why are we not connected to Twitch? One sec. I know why. My bad. I need to reconnect. One sec. Yeah, it wants all my permissions, whatever. Thank you for letting me know that, Anders. Yeah, I have to refresh the tokens every once in a while on Twitch. Okay, so now it should be working. There we go. Let's see if I can turn on. Can I gift myself baby voice? There we go. Oh, it's on a cooldown. All right. Let's see if Master Chief works. Oh yeah, see now Master Chief works. Okay. Okay. Close that. There we go. All right. So wait, what was this? So this is 5 plus 3 times 2. So the answer should be 11. Pretty sure that's right. I'm tempted to go into undergrad math, but then I'm gonna need to touch further math, mechanics, and stats. Stats is pretty cool. All right, let's see. Dry Nose, you asked this question. You said your finals tomorrow, Dry Nose? That was Chewbacca. I love Chewbacca. Ooh, tomorrow is the last 3 episodes of Andor. Andor is like the best thing to ever come out of Star Wars. That and like Rogue One. I love everything there. Okay, let's see, Dry Nose. So you said let f of x be a function which is an alternating series. Okay, g of the function is the integral of the series. Sorry, what? Find the first 4 non-zero terms and the general term for the power series expansion of g of x about x equals 0. I see. Wow, we're up to 3.2k. That's so many likes. Okay. Okay. Well, let's look up the terms, right? So f of 1. So that's going to be negative 1. So that's going to be equal to 1, right? It's negative 1 squared, which is 1. And then that's going to be t to the 6th over 4 factorial. Okay, cool. So t to the 6th over 4 factorial. Okay, then f of 2. Well, that's going to be negative 1 because that's to the 3rd. And then that's going to be t to the 9th over 6 factorial. Okay. And then I think I see a pattern here, right? F of 3. It's going to be positive. But then that's going to be t to the 12th, I think. Right. T to the 12th over 8 factorial. Oh, okay, cool. I see a pattern here. Right? Then f of 4 is equal to t to the 15th over 10 factorial. All right, so now you want me to integrate that from 0 to x. And then the power series expansion, well, that's like a Taylor series of this, which, I mean, dg dx is just equal to f of t. And then it's just x minus 0 squared. So this is it, right? And then then the series expansion. An analogy of giving math problems to the site is like therapy, but math's very therapeutic. Oh, well, that's cool, actually, man. Yeah, it's like if we talk about our problems enough and, hear them out loud, we start realizing they're not very they're kind of ridiculous and not really that scary. Or like we're worried over nothing. Anyways, so a power series expansion, this is a Taylor series, which is usually like, I don't know, it's like f of 0, and then it's like f prime of 0, x minus 0 to the 1st over like 1 factorial or something, plus like f double prime, x minus 0 squared, and then it's 2 factorial. Well, isn't it f of x instead of f of t? Well, here's the key thing. Oh, you're right, it is. Sorry, my bad. Yes. What I meant to say is, like, so if you take the derivative of an integral, and then this is just chilling up here, this just, like, gets put inside. So you're right, it is just f of x. Which to me, I don't know, it's weird. It's weird that we're saying, oh, well, g is the integral this way, but now I want the power series expansion. And it's like, okay, but the derivative's just going to take out the integral anyways. It's like, what's the point? But in general, right, if I integrate this, well, here we can just integrate it from this standpoint, right? Integral of f of t dt. Like each term, this is going to come out, this is going to come out, and it's going to converge because you got something factorial on the bottom over the top here. So you're just going to get 2 to the 3n plus 4 over 3n plus 4. And then that's going to be 2n plus 2 factorial negative 1 to the n plus 1. Right? This is, and then there's a series here from n equals 1 to infinity. And that right there is g of x. Okay? So then, yeah, integrating this, right? That's just like t to the 7th over 7 times 4 factorial. What was 4 factorial? 4 factorial is what? 4 times 3 is 12. 24. Yeah, so that's t to the 7th over 7 times 24, which is 100 and... that's 140, 28, 168. Okay, so you go through and just like integrate these. Great. Who cares? And then so yeah, the power series expansion. Is this just all it is? Because I feel like doing a Taylor series of this, you're just gonna eliminate this anyways. You're just gonna get G of X. It's not really bad. That's not hard. 4.5K motion. You've been slamming, dude. Slamming that like button.
That's dope.
Okay, I'm getting tired. Do we have any other quick questions in the streams? Someone wanted me to do this one. Is this one solvable? Or someone yanking my chain here? Yeah, Emotion's like, I'm tired of smashing the like button, dude. We're up to 4.5K likes, dude. At what point is TikTok gonna think that this is suspicious? Okay. A plus B is equal to 1. Your Sharingan. What's your Sharingan? Oh, was that the red looking... Is that this? Sorry, is this your Sharingan? What's Sharingan mean? Sorry, by the way. Is it this thing? Is this a Sharingan? Oh, the red eyes. Oh, that's why you submitted that. Oh. I think I see what he's talking about. Wait, not this one. Yeah, no, you sent it. I'm just trying to get it like this. You're saying that his eyes here represent this? Aura, okay. The diagram displays 6 polar curves restricted to the region R is greater than less than 2. The curves are shown within a radius of this. Use calculus to find the percentage of the circle that is shaded. Wow. Well, I assume I can just figure out what like the area of like one of these petals is, right? Oh, wait, but there's overlap. Oh, that's so annoying though. Dude, what? No, how do you do this? Because even if I get one of these petals, then I'm double counting here. Oh, man. This seems like way too many equations. I mean, these are phase shifts, I guess, is what's happening. Yes, they are polar equations, but I don't know which ones are labeled to which ones. Or I'd have to figure out all of them. Is this a real question? I'm gonna throw this one at ChatGPT. I'm gonna go kill some dolphins. Oh, y'all made it. Oh, that's cool. Yeah, I mean, I know that the total area, right? Total area. That's equal to, you know, 4 pi. What's up, Dissident Font? R is less than 2 at the top. Well, everywhere R is less than 2. So the total area there is F high, yeah, high actual education. I like that, the X and Y. That's fun. Yeah, my question here though is, like, is this spanned by a nice thing? Because then I can just find like what one of these are, right? And then I need the I need to know where they intersect and stuff, right? Or they're all cardioids. A Sharingan move on the homie. Dude, now I need to know what this Sharingan thing is. Y'all keep saying this shit. I don't know what it is. Oh, it's the eyes. Oh, okay. Why does this guy have such weird looking eyes, dude? That's kind of cool. What's up, Gucci Gouda? Yeah, in order to integrate this, well, first of all, I'd have to create all these graphs. So here, we can try to look at it. Watch. So here we go. So here, we can do this. Let's try putting this into Desmos. I'm curious. Okay. And then I think I need to set it. Do I have to set it to polar graphic mode? Is there a way to do that? Do I have to make this as X? What do I have to do? There we go. That's what we have to do. Sorry, I just gotta replace all these. Oh, wow. Look at this. Well, that's really cool, man. So what are you doing here? Oh, you're just offsetting the phasing on it, right? And then you're also moving the radius of it. Wow. Okay. Desmos, it is very pretty. So, yeah, the only issue with this, right, is I'd have to figure out what the intersection is here. Here, let's... Yeah, so if, for instance, I see just like this petal, for instance, right? That petal, I believe, is created from the purple line here. And then I want to say it's also the red line here. Yeah, draw the circle radius too as well. Yeah. I'm going out too far? You think so? Well, I think it's this, right? So I believe that's what this is. Oh, I have. You are right. Yeah, all good, disinfluence, yeah. Wait, I'm trying to figure out where... How did you make this shape, though? How is this pedal happening? How's this pedal happening here? I don't see it. Because wait, it looks like it touches here, no? But I don't see anything touching out here. So I'm not sure if all these equations describe it. If I recall, there's 6 pedals. Yeah. Well, here I see it definitely touch 1, 2, 3, 4, probably like 5, and then there's a 6th one here. But it doesn't necessarily form pedals. So maybe check these. I think these equations might not be exactly correct to describe this. Okay. But anyways, that's good. I don't think we have any other questions for today. Well, that was fun. We had a lot of really fun ones today, though. Okay. All right. Shrink it to radius 2. Oh, you're so right. Sorry, Femvox. I was looking at radius 4. Oh my god. Femvox is so right. Okay. I see it now. I see it. So now it's this. That was Femvox. Yeah, that was Femvox. Femvox is always like kind of watching out for me. Okay. So then you just need between where like the blue and this intersect, okay, to get this area, multiply it by 6, but then you need to subtract. So you need where the blue here and the purple intersect. And then once you have this, you need to subtract. I want to say you want. I think you have to subtract where like the green and the blue meet, like where these two meet. You gotta subtract that, because otherwise you're double counting it, right? If you multiply that by 6. Average 2 marker GCSE question. No, this would be tough without a graphing calculator, because you definitely. I wouldn't see that that's the intersection between the two. So wait, which one is the purple and the blue? Oh, break the red into equal parts. Oh, so you're saying break, yeah, instead of doing the double counting, you're saying do this. Right? So that's just where the green and the black intersect. Yeah. Okay. All right, I'm gonna close the stream up. I'm getting a little tired, but cool. It's a cool question. All right. Thanks everyone for coming out to office hours today. Really appreciate all the questions, all the fun stuff we're going through. Our next stream will be tomorrow. That one will be earlier. It'll be at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. So come on by if you want to get help with different math and science. Yeah, fun problems today. Sorry, I was kind of running out of steam at the end there to start doing polar integration. Yeah, you're very welcome, Anders. I appreciate all you guys. So again, come by the stream tomorrow. We'll have more help for you guys. And then yeah, stay in touch, stay in tune on the Discord. If you want a chance to win up to $20, all you have to do is like spend 20 minutes going through our friend Nick's fun little geometry program he built. It's this. It's called Wibbly, is what it is. He built kind of like a tree node way of like learning math. And he just wants like some cool feedback. So if you guys want to give feedback, he would love it. So it's like arranging knowledge into like all these cool little trees. So like, oh, let's go into math. Oh, within math, what can you learn? It's like, oh, here's the geometry tree. I guess it's showing how like, you know, everything is connected as a web. And he's got some cool you know, information here, and he just wants to get a little bit of feedback. So yeah, check that out on the Discord. I'll give instructions for how to participate in that if you want. It probably is Node.js, honestly, Laz. He coded it all himself, this guy Nick. He's a pretty cool guy. But maybe do you recognize the animations and stuff? Like if I go into like, I don't know, it's like, what is it, trig. And then we have like trig ratios, like theorems, triangles. You can like go up and down and stuff, yeah. But is it path connected, arc connected, or just simply connected? No one knows. But yeah, stay in touch on Discord, and yeah, stay tuned, and we'll let you know about that one. All right, let's go raid somebody. Ooh, physics and depression. You guys want to go check out physics and depression? He's doing more physics stuff. I like physics and depression. He's a cool guy. They are both. Are they nodes or antinodes? Yeah. Ooh, okay. Oh, he's doing electricity. So physics and depression is doing. This is like E&M stuff. This is cool for like circuits. So here, let's go raid. Say hi to him. Otherwise, awesome. Have a great start to your week, everybody. We will see you guys tomorrow. Peace out.
Under one end, you know, the fluid itself might be moving very slowly, but if it's